This is the 3.1 homework help video. I've had a couple of kids come in for tutoring in the mornings the last couple of days, and I answered a few questions in class today, but I want to make sure that you guys understand this assignment and that you really get how to tell if a relation is a function. So we've been talking about what a relation is and what a function is for about 3 days now. So just to review, a relation is just a set of ordered pairs. A function is a special type of relation where every x is paired with only one y value, meaning that no x's are going to repeat with different y values. So we looked at several representations of data, and the first one that we looked at was a table, an input-output table. Remember, input's just another word for x, and output's another word for y. So if we're trying to determine if a relation is a function, what we need to focus on first are the x values. So if you look at number 1 on your homework, you see the x values here are 8, 4, 2, 4, and 8. So several of these values repeat. So 8 is paired with -4 right here, and 8 is paired with +4. 4 is paired with -2, and 4 is paired with +2. So I can see that I have x values repeating, and they're repeating with different y's. Therefore, for number 1, this is not a function. It's not a function because we have x values repeating with different y values. Okay? More specifically, 8 repeats with 2 different outputs. So does 4. Okay? So when you're saying that it's not a function, you need to use the definition to explain why it's not a function. So this is not a function because the 8, and you could also use the 4 because it repeated with 2 different y's, but I used 8. So 8 repeats with 2 different output values. Okay? So you should be able to do number 2 based on the explanation that I just gave for number 1. So if you want, you can pause the video. I will not be doing that for you to check your work, but you should be able to look at the x values, see if they repeat, and if it is or is not a function. Don't forget to explain. So I'm not actually going to do number 3 and 4 for you. However, I do want to review the vertical line test with you, which we actually talked about in class again today when we were talking about the card sort, but some of you were a little iffy on it. So the vertical line test says that if you draw a vertical line, so that's what you want to do. You're drawing a vertical line, or you can just lay your pencil on your paper. Remember, a vertical line is a line that goes up and down. So you draw a vertical line, and you're trying to make sure that that line does not touch the graph in 2 or more places at the same time. Okay? So draw a vertical line. That line should touch the graph in one place, and no more than one place at the same time. Okay? In order to be a function. Remember, if it's touching the graph in 2 or more places at the same time, what that means is that x is repeating. That's the only way that you're going to touch the graph in 2 places at the same time with a vertical line. And in order to be a function, no x can repeat with a different y. Okay? Don't forget when you do this part, you do have to explain why it is passing or failing the vertical line test. Okay? So go ahead and do 3 and 4, and then restart the video for the next section. Now this next section is a little more detailed, and I do want to do these with you just to make sure that we are on the same page with domain and range. This is a big deal, okay? So For 5 and 6, it asks you to find the domain and range of the function represented by the graph. So when we did this on Friday and Monday, we talked about the different types of data. So individual data points, like what you see on number 5, is called discrete data. So notice on number 5, I have actual individual data points on my graph, okay? So that's called discrete data. Data that is connected with a smooth line or curve is called continuous data. It's important that you can distinguish between the two types of data because that tells you how you're going to write your domain and range, okay? So for discrete data, remember those are the ones that you make a list. So the first thing that you have to do is you need to look at the ordered pairs that are on your graph. So this first point, which is right here, the ordered pair for that is -3, 2, okay? I need that ordered pair to write my domain and range. The point that is located right here on the x-axis, that one is -1, 0. The one that's located on the y-axis up here is 0, 3. We've got a point located here at 1, 2. And then we have a point down here on our x-axis that is at 3, 0. Okay, once you have all your ordered pairs, the next thing you have to remember is that domain is the set of all your x values, and range is the set of all your y values. So in order to write domain and range, to write domain, you're going to have your D. So we know that we're looking at domain, colon. You're going to draw a bracket, and you're going to list your x values from least to greatest here. So we have -3, -1, 0, 1, 3. Okay? And I got those by looking at the x coordinates of my ordered pairs. Okay? So I was just looking at x. Why don't you pause and based on this, see if you guys can write the range. Then you can start the video and check your work with mine. Okay, so for your range, what you should have noticed is that some of the values repeated, which that's fine. So I just looked at my y values here, and I noticed that some of them repeated, which that's fine. I just listed them once, okay? So I have 0, and that happened twice, but I just listed it once. I have 2, that happened twice, but I just listed it once. And then I have 3, okay? And those are inside brackets. So discrete data, you're going to write like this. You're just going to simply list out your x values and list out your y values. Now for continuous data, it's a little bit different. And so we talked about this. We talked about that domain are the set of all your x values. So what you want to do is you want to go to your leftmost point and you want to draw a line that passes through it. Then you want to go to your rightmost point and draw a line that passes through it. Okay? That's going to show you the interval that you're trying to look at. Okay? This one kind of didn't go straight through. Let me redraw that. So you want to draw a line that passes through that point so that you can see the interval that you're looking at. Now the word interval should give you a hint. If you notice that all the x values fall between those two boundaries, you're going to be writing an inequality. Okay, so my lower part, the smallest x value, is -1. That's less than or equal to x, which is less than or equal to your highest x value. So my biggest x value is right here, notice, and that's at 3. So I know that all of my x values fall between -1 and 3. So it's read as -1 is less than or equal to x, which is less than or equal to 3. Okay? All right, so let's go ahead and look at my range. So for your range is dealing with y. So you want to go to your lowest point on the graph and draw a line, and your highest point on the graph and draw a line. Okay? and that's going to help you look for your boundaries. So my lowest point on the graph occurred at, so I'm looking right here, see where it's crossing the y-axis, and that's at -4. So -4 is less than or equal to y, which is less than or equal to my highest y value occurred right there, which is at +8. Okay? So look at the difference between discrete and continuous data. Discrete data, which is the points, we list our domain and range. Continuous data, which is data that's connected with a smooth line or curve, we write as an inequality. Okay? All right. If you have any questions about that, please ask me, because domain and range is a big deal. When you're given a word problem, the first thing you need to determine is whether or not the word problem is discrete or continuous. So remember, we talked about discrete data. Generally, those are going to be things that make sense as whole values, specific numbers within the set of X. So let's look at this one. This says that we're talking about a function that's representing monthly cost in dollars of a group of members joining the fitness club. Well, right here they tell you that X is the number of members. Well, those are people. So when you're talking about people, does it make sense to have parts of people? Would decimals make sense? Would fractions make sense? And hopefully you know that the answer is no. You're going to have 0 people, or 1 person, or 2 people, and so on and so forth. Okay? So for letter A, identifying the independent and dependent variables, remember your independent variable is the things that you're plugging in for X. So it actually gave us that in the problem. So I know that independent, that's X, that would be the members joining the fitness club. Okay? Then the dependent variable, well, that's your output, that's your Y value. Well, it told you right here that's your monthly cost in dollars, right? So that's your Y value, so that has to be your dependent variable. Now here's where things get a little tricky. If you look at B, it says your group has enough money for up to 6 members to join the fitness club, and they want you to find your domain and range, okay? So remember, domain is X, so domain is the number of members joining. Well, if you have enough money to join for up to 6, what does that mean for your domain? Well, we already determined that we have a discrete set of data, so I know that I'm going to be listing numbers. So up to 6 people, well, that'd be 0 people could join, which wouldn't really make sense, but that's a possible set. 1 person could join, 2 people could join, 3 people could join, 4, 5, and up to 6. So I stop at 6. Notice I have several input values. I have several X values, 0 all the way up to 6. But I listed them because I wouldn't say I have half a person joining. Okay? All right, once you have your domain, finding your range should be easy. The nice thing is they did give me a function rule. They gave me an equation. So there's a couple of ways you could do this. You could simply plug in the numbers that you have into the function and do the math, or you can use your calculator, which is what I'm going to do. So remember, you go to y equals, which is the button in the upper left-hand corner, and you want to put in 7x plus 35. Now, I want to view my table of values because I want to see what each of the domain values that I wrote down is paired with. So I press second and graph. That shows me my table. Now I can see that 0 is paired with 35, 1 is paired with 42, 2 is paired with 49, 3 is paired with 56, 4 is paired with 63, 5 is paired with 70, and 6 is paired with 77. So that would be the range that goes with this. So remember, if you don't have a calculator, that's okay. You just plug in 0 where X is and solve. 7 times 0 was 0, plus 35 is 35. Then you plug in a 1 and you do the math. And that's where these numbers are coming from. Okay? So we actually talked about number 8 in class today. This last section is asking you that if the word problems here are using the term function correctly. So remember the definition of a function. In a function, every x is paired with the same, like with one y value. Like x is not going to repeat with different y's. So the example I used in class today was number 8. This says a function pairs each teacher with 30 students. So if you think about that, that would be like taking me, Miss Watson. So if I am paired with Jamari, and I am paired with Brooke, and I am paired with Michael, and I am paired with Sebastian, and so on and so forth. That would be me, 1x, being paired with 30 different students, 30 different y values. So if you have one x that's repeating over and over and over again with different y's, is that a function? And we decided today in class that no, it's not a function because every x has to be paired with a different y value. So this one, this is a little bit trickier because you have to explain your reasoning. So that means think about it and then being able to communicate your answer in writing. So you guys go ahead and do number 8 and 9. And once you do that, you're finished with your homework, and I will see you in class tomorrow. Have a great night.